topic is understanding drawbacks of services, type load balancer, and how Ingress changes the flow, and how enterprise level capabilities are provided by Ingress. Drawbacks of services type load balancer. While a service of type load balancer works, it is inefficient for enterprise level scaling for two main reasons, that is cost and resource exhaustion. Every time we create a load balancer service, our cloud provider, that is AWS, GCP or Azure or other providers, provisions a network load balancer, that is NLB, and a static IP address. If we have 50 microservices, we pay for 50 load balancers. This is expensive and difficult to manage. Lack of layer 7 intelligence. Standard services operate mostly at the transport layer, that is layer 4. They can route traffic based on IP and port, but they cannot look inside the traffic route based on URL path, that is example /API//API versus /web, or manage SSL certificates for multiple domains on a single IP. We know that load balancer is one of the services provided by Kubernetes services. There are cluster IP, node port, and load balancer. Load balancer is for balancing the load across the pod. The services load balancer type provided by Kubernetes only offers round-robin load balancing, not enterprise level benefits or scaling. These are offered by Ingress controller, for example, that is Nginx. So one of them would be cost and resource exhaustion. For every service type load balancer, we create network load balancer and a static IP address. And if suppose we have many microservices, that is example 50, we should be paying for the 50 load balancers, which would be expensive and difficult to manage. Whereas if we have Ingress that would manage that, and instead of many load balancers, there would be only a single load balancer with many services that is managed by Ingress controller and Ingress. It doesn't have layer 7 intelligence, which means it cannot look inside the traffic to route based on URL path, or to manage SSL certificates which are required for HTTPS secure website for multiple domains on a single IP. That is also managed and provided by Ingress. Now, how Ingress changes the flow. Instead of giving services its own entry point, Ingress acts as a single front door for the entire cluster. So the workflow would be deployment of Ingress controller. We deploy a controller like Nginx, HA proxy or traffic. This controller is backed by one single cloud load balancer. Creation of Ingress rules. The user or the developer creates an Ingress YAML file. This file contains the routing rules, for example, sending the traffic on example.com/shop, https://example.com/shop to the shopping service. The watcher mechanism. The Ingress controller constantly watches the Kubernetes API. The moment we apply our YAML, the controller detects it and automatically updates its internal configuration, for example, updating the nginx.config dynamically. So workflow for applying Ingress would be, we would first create Ingress YAML file that would have routing rules. For example, that would be sending the traffic for example.com shop. For example, sending traffic to certain domains and subdomains. Simply it contains the routing rules, and we apply that YAML file. And we would be assuming that that YAML file would be enough to create our Ingress configuration and to provide services of enterprise level. But it doesn't happen that way. It needs Ingress controller to manage those rules or routing rules provided in the Ingress YAML file. Then we would be deploying the Ingress controller. For example, there are many, that is Nginx, HA proxy or traffic. These controllers are backed by one single cloud load balancer. So after we deploy the Ingress controller, the Ingress controller constantly watches the Kubernetes API. The controller automatically detects it and updates its internal configuration, that is, it updates the nginx.configuration dynamically. So before Ingress controller, we would be applying the YAML file of Ingress and it wouldn't do anything, or it wouldn't update or doesn't have anything. But after we deploy Ingress controller, the controller automatically detects and updates the configuration of it. Simply we can understand it by knowing that relationship between YAML file of Ingress and Ingress controller is same as your device and operating system. Without the operating system, your device wouldn't work. So it's same. Ingress controller is like the operating system. Without it, YAML file is of no use. So we apply for the YAML file and we deploy the Ingress controller. So it is simply like the operating system for the Ingress YAML file to make it work. Now, enterprise level capabilities provided by Ingress. When the Ingress controller processes our YAML, it provides features that a standard service cannot, which is content-based routing. We can host multiple applications behind a single IP address using host-based routing, which is app1.company.com and app2.company.com. Both point to the same IP but go to the different services. Path-based routing, that is company.com/login, https company.com/login goes to the authentication service, while company.com/search, that is https company.com/search goes to the search service. So we know that to save the cost to provide enterprise level benefits and services, there is a concept of Ingress, which is not where typical load balancer by Kubernetes services doesn't provide. So typically we would assume that we would need multiple load balancer to manage the services and routing. It is not like that, because Ingress controller provides host-based routing, which is if the domain, that is app1.company.com, and there is domain app2.company.com, both can have same single IP address but can go to different services with respect to their domain. So we save the cost of static load balancer service. And for path-based routing, it would be for the same IP, it would company.com/login goes to authentication service, while company.com/search would go to search service. SSL or TLS termination. Instead of managing SSL certificates on every single pod or service, we upload the certificate to the Ingress controller. It handles the decryption at the edge, saving CPU cycles for our internal applications, which would be advanced traffic control. Ingress controller like Nginx allow for rate limiting, preventing DDoS attack by limiting requests per second. Authentication, requiring a login before the traffic even reaches our internal service. Whitelisting, allowing only specific IP addresses to access certain parts of our application. So SSL certifications are required to secure our websites. SSL certificates provide HTTPS to the website. So instead of managing those certificates on every single pod or service, we upload the certificate to the Ingress controller and it handles all the decryption, saving CPU cycles for our internal applications. And it also provides rate limiting, authentication, whitelisting, blacklisting, all these benefits as well. Now the summary would be: feature, that is cloud cost. For service type load balancer, it is high, that is one load balancer per service, whereas in Ingress with controller it is low, that is one load balancer for many services. Feature, that is IP addresses. For the service type load balancer, it is multiple static IPs required, whereas for Ingress with controller it is single static IP. Feature, that is routing. For service type load balancer, it is simple port/IP routing, whereas for Ingress with controller it is complex URL or path routing. Feature, SSL management. It is for service type load balancer it is complex or individual, whereas for Ingress with controller it is centralized at the controller. Feature, that is logic layer. For service type load balancer it is layer 4 network. For Ingress with controller it is layer 7, that is application. So that is it for the video today. Thanks so much for watching. Have a good day. Bye.